Welcome to this video, where we explore how Life Cycle Assessment, or LCA, is integrated into Environmental Impact Assessments, or EIAs, to achieve a truly comprehensive understanding of a project's environmental footprint. This integration is key to unlocking deeper insights and driving genuine sustainability. Life Cycle Assessment, LCA, is a powerful methodology that systematically evaluates the environmental impacts associated with all stages of a product's or project's life cycle. This includes everything from the extraction of raw materials, through manufacturing, transportation, use, and finally, to disposal or recycling. When integrated with a traditional environmental impact assessment, EIA, LCA provides a significantly broader and more comprehensive understanding of environmental impacts. While a standard EIA might focus primarily on the direct, on-site impacts of a project, combining it with LCA allows for the consideration of upstream and downstream consequences, impacts that might otherwise be overlooked but are critical to true sustainability. This holistic view helps reveal hidden environmental burdens throughout a project's entire value chain. The synergy between LCA and EIA offers several compelling benefits. Broader scope of assessment. It extends the analysis beyond immediate project boundaries, covering the entire life cycle of materials, energy, and waste. More informed decision-making. By analyzing the environmental impacts of various alternatives early in the planning process, decision-makers can choose options with lower overall environmental burdens. Improved compliance. This integrated approach helps organizations better align with stringent environmental standards, such as ISO 14001, which emphasizes life cycle thinking. Enhanced transparency and credibility. Demonstrating a comprehensive understanding of impacts, from cradle to grave, builds greater trust with stakeholders and enhances a project's environmental credibility. Identification of hotspots. LCA helps pinpoint specific stages in a project's life cycle that contribute most significantly to environmental impacts, allowing for targeted mitigation efforts. LCA is typically conducted in 4 standardized phases. 1. Goal and scope definition. This initial phase defines the purpose of the LCA, the functional unit, what is being measured, e.g., 1 cubic meter of concrete delivered, the system boundaries, what processes are included, and the level of detail required for the study. 2. Inventory analysis, LCI. This is the data collection phase. It involves compiling a detailed inventory of all relevant inputs, e.g., raw materials, energy, water, and outputs, e.g., emissions to air, water, and soil, waste, throughout the defined life cycle. This can be a very data-intensive process. 3. Impact assessment, LCIA. In this phase, the inventory data is translated into environmental impact categories. These categories represent different types of environmental problems, such as climate change, measured by CO2 equivalents, ozone depletion, acidification, eutrophication, and human toxicity. This phase quantifies the potential severity of various impacts. 4. Interpretation. The final phase involves analyzing the results from the impact assessment to draw conclusions, identify significant environmental hotspots, evaluate data completeness and consistency, and make recommendations for improvement. This phase often includes sensitivity analysis and uncertainty assessment. While highly beneficial, integrating LCA can present challenges. Data availability. Obtaining comprehensive and reliable data for every stage of a project's life cycle can be difficult. Solution. Utilize trusted industry databases, proxy data from similar projects, or conduct preliminary assessments with available data. Complexity. The sheer volume of data and the intricate nature of interconnected processes can make LCA seem daunting. Solution. Start with simplified assessments focusing on key impact areas, and gradually increase complexity as data and expertise grow. Utilizing specialized LCA software tools can also significantly streamline the process. Time constraints. Conducting a full-scale LCA can be time-consuming, especially for complex projects. Solution. Employ standardized templates, checklists, and streamlined methodologies. Prioritize the most significant impacts based on initial screening or expert judgment. The use of tools like the free ISO 14001 Lifecycle Assessment Template, often available in Excel, can also significantly aid in getting started. In conclusion, integrating lifecycle assessment into environmental impact assessment provides a more robust and holistic understanding of a project's environmental performance. It offers deeper insights for more sustainable design choices and comprehensive planning, which is essential for organizations committed to long-term environmental responsibility. Thank you for exploring the powerful combination of life cycle assessment and environmental impact assessment. We hope this has clarified how these tools can drive genuine sustainability in your projects. If you found this video informative, please give it a like and subscribe to our channel. For more content on environmental assessment and sustainable practices, visit assessmentstools.com.